So basically what we're looking to do is show that the coordinates of the midpoint of a segment AB with coordinates x1, y1, x2, y2 as shown, that those coordinates are x1 plus x2 over 2, y1 plus y2 over 2. So what we're going to do is imagine that AB is in a coordinate plane. We're going to form a right triangle dropping a vertical segment from B to C and from horizontal segment over from A to C. And M, P, and Q are going to be midpoints. Now, our key step here is we're going to draw segment MQ. And then we want to look at triangles AMQ and ABC and show that they're similar. Thinking back to geometry, we can prove that two triangles are similar. One of our methods is the side angle side triangle similarity theorem. And you'll notice the scale factor of AM to AB and AQ to AC is 1 to 2, and that both those two triangles share angle A as a reflexive angle. Therefore, we get those two triangles similar. That means then corresponding angles in similar triangles are congruent. We had shown before that BC and AC are a vertical and a horizontal line. They're perpendicular, which gets a right angle. So therefore angle MQA is going to be a right angle. We also then know that if the scale factor is 1 to 2, let's call segment MQ length T, and then note that since P is a midpoint, CP and PB will each have a length of T. So if MQ and PC each have a length of T, that would mean that M and P will have the same Y coordinates. So let's see if we can figure out what the Y coordinate of P is. The length of BC is going to be Y2 minus Y1. If I take that and divide that by 2, that will give me T. So Y2 minus Y1 over 2 is T. So then the Y coordinate of P then will be, I'm going to add I want to add T to the Y coordinate of C, which is Y1. So Y1 plus Y2 minus Y1 over 2 turns out to be Y1 plus Y2 over 2. And since M and P have the same Y coordinates, then therefore my Y coordinate of M will be Y1 plus Y2 over 2. So by similar method, if I look at segment AC, I can find the X coordinate of Q, and the X coordinate of Q is going to be the same as the X coordinate of M, because MQ is a vertical line. So therefore my length of AC is going to be x2 minus x1. Divide that by 2 since Q is a midpoint, so that's x2 minus x1 over 2. Add that to the X coordinate of A, which is x1. So my Y coordinate of Q, when I simplify, is x1 plus x2 over 2, and that X coordinate of Q is also the X coordinate of M, so M's X coordinate is x1 plus x2 over 2. Again, a reminder that Q and M have the same X coordinate because from the similar triangles, the angles being corresponding angles being congruent, since C is a right angle, angle MQA is a right angle, therefore MQ and BC are both vertical segments, and we know that all the X coordinates on vertical segments in the coordinate plane are the same. So in summary, we then have shown that if you got a segment in the coordinate plane whose endpoints are x1, y1 and x2, y2, the coordinates of the midpoint are the X coordinate will be the average of the two X coordinates, x1 plus x2 over 2, and the Y coordinate of the midpoint will be the average of the two Y coordinates, y1 plus y2 over 2. Simple formula from Algebra 1 and geometry, but one a formula that's going to be useful for you.